Welcome to a supplemental video regarding radicals. The idea here is just an introduction to radicals before we move on to how to deal with radicals in terms of adding, subtracting, multiplying, dividing, which we will get to. This is more of what is a radical. It's not anything new. If you've dealt with square roots, you've dealt with radicals. In fact, all radical is, if you want to call it something different, is a root that has a different power than 2. So most people have dealt with square roots a little bit. So if you get a problem that looks like, let's say square root of 16. Now, if you've done roots before, you know the answer is 4. You get that because 4 times 4 is 16. You're kind of going in reverse here. But in this case, what you also have here is something that's kind of unwritten. Anytime you see a root, basically a square root symbol, without a number, you always assume there's a 2 out there. So that basically says the second root of 16, in this case, will give us 4. Again, going in reverse. So when you get to radicals, it's anything new, it's just more numbers you have to deal with. So let's say you have something that looks like the cube root. So you write your square root, you write your root symbol. I'm not going to call it square root because we're not dealing with squares here. But you deal with your root symbol, and it's a cube root of 27. So in this case, you have to ask yourself, I have 3 things I have to multiply together to get 27. So what times what times what will give me 27? Just like when you're dealing with square roots, a lot of it is in memorization or knowing what table to look up. Because once you know what table to look up, then you basically, most books, if you're taking a class or places online, will give you a listing of square root of 4 is 2, square root of 16 is 4, square root of 25 is 5. There's very similar things with cube roots. And normally you don't have to go too high. So in this case, the cube root of 27, well, you have to think, let's start at the low end. Let's start 2. 2 times 2, there we go, times 2. Well, 2 times 2 is 4, times 2 is 8. Obviously, not 27. Also, 27 is an odd number, so it can't really be any even number when you multiply to get it. So in this case, you would have, let's try 3. 3 times 3 times 3. Well, 3 times 3 is 27. Times 3 again, 3 times 3 is 9. 9 times 3 is 27. So we multiply the cube root of 27 in this case will give us 3. The other way to think about it is saying, well, if I'm going reverse, again, 3 cubed gives us 27. Now this number here can be any whole number in reality. So let's say you have a number that can be much higher than that. So you can have, let's say, a 5th root. Okay, so you're talking, let's say, the 5th root of 343. Now obviously a 5th root means you have to multiply something 5 times together. This is why when you deal with these higher powered radicals, you normally don't deal with very large numbers. Mainly because the numbers get very large very quick. Let's take 2 as an example. Okay, we have 2. 2 squared being 4. 2 cubed, just keep multiplying 2, 8. Next level up, 16. Then 32. So you notice in this type, 5 times, doing it 5th root gives us 32, which is, can get a big number real quick. If you deal with, let's say, 5. Okay, we start 5. 5 times 5 being 25. So square root of 25 brings us back to 5. Next number up, just multiply by 5. 125. So 5 cubed already up to 125. We multiply by 5 again. 625 is 2/4. Or you can think about the 4th root of 625 is 2. Notice how you're going in two directions here. You're going in two directions there. So for 343, the fifth root, again, is 3. So when you're talking about these, basically as square roots with something other than a 2 out in front, just a straight root, you have, this isn't something that's easily calculable by the basic algebra student. It's something that you have to get a feeling for what number to go to and what table to start off with. And once you do that a few times, then you'll get comfortable with saying, I see a number there, it's in the low hundreds, it's to the third root, so I know the number has to be pretty small to start off with. Hope this helped, and look forward for more videos coming up.